Now, we already talked about one type of an angle. Do you remember that angle that, that met at the center of the circle?
Inscribed angle.
Was it an inscribed angle? Is that what we called it?
Oh, center.
The center angle?
Intercepted arc.
What is it? Central angle. It's the central, okay? It's the center of the circle, so it's the central angle. Now, what did we say? Let me just review really quick here. All right, so if I had an angle like right here and right here, right, this angle right here that I'm pointing at, that's the central angle. What do we say about the central angle and the arc that it cuts off? Or it's intercepted arc. A lot of times we'll say it like that, okay? It's intercepted arc. Does that make sense to you? Wherever the angle hits right here and right here, this arc is the intercepted arc. If I wanted to label it, I could. So, and we'll call this C. All right, so this angle is angle C, but what's the name for it? Say it again, Alex. Central angle. Okay, so the central angle, what's the relationship between the central angle and the arc that it cuts off, or the intercepted arc? What is it? They're the same. They're congruent to each other. Exactly right. All right, so if I said that this was, I don't know, 70 degrees, and then I asked, okay, what is arc AB? Well, arc AB is also 70 degrees. Doesn't get a whole lot easier than that, does it? All right, because they're exactly equal to each other. You don't really have to do much to it. All right, let's change this around just a little bit, though. Let's get rid of these. All right, let's get rid of that. Get rid of this B. And get rid of the 70. Get rid of the A. And we're good to go again. Now, this time, we're going to draw another angle, but we're not, the vertex of the angle is not going to be at the center of the angle. The vertex of the angle is going to be actually on the circle itself. Remember what we said on the circle? It has to be on that line. A lot of people think on the circle is this. They think it's like a disc, like it's a frisbee or something, or a plate, you know, and we're saying, oh, we're on it. Are we really on it here? No, that's in it, right. This is outside, and this is where? On the circle. So this angle I'm going to draw, the vertex is actually on the circle. So I'm going to draw an angle that goes to here, and it's got to go far enough so it at least hits the circle on the other end. All right. They are two chords, but two chords form a what? If they have the same vertex, they form what? An angle. All right. So I've got an angle right here. And actually, let's do that. We'll just call this theta again. Oh, what's wrong with theta? You don't like that? You'll get used to it. Theta is a very common thing people use for an unknown angle. All right. So watch this. What's that? Scientologists called the body theta?
Yeah.
Did they really? The soul? They called it theta?
Yeah.
Really?
They call like individual soul a Satan. I think like collectively it's called theta.
Oh, really? Is that taken from the Greek word, the alphabet and stuff? Is it really? Wow. That's something new. I didn't know that. So next time I run into Tom Cruise, I'll have to ask him about that, right? All right, so here we go. This is just, this is nothing satanic, nothing or anything like that. It's just a Greek letter of the alphabet. That's all it is, all right? So that's theta. Now, watch this. Look at this angle right here, and then look at this arc, and let's name it again. We'll go ABC. I'm real creative, aren't I? All right, so we'll talk about arc AC. Look at this arc right here, and look at this angle right here. Do you think they're going to be equal to each other? No, they're only equal to each other when it cuts off the central angle, right? So there is a relationship, though, all right, that this arc, you could look at it two ways. You could say this arc, what do you think, just off the top of your head? It's a nice, easy relationship. It's nothing real crazy. What do you think, Monica? You think it's equal to this? No, because if it went from here to here, right, and from the center to here, it would be equal to that central angle. I'll tell you what, let's do that. Since you mentioned that, let's, and Daniel, I know, I'll give you a second. Just hang on to that, and I'll let you say it. But let me do this real quick. Let's go to there. Yeah, I made it red. Thanks. All right, look at this right here. Do you see this angle? Right there? That's a central angle, isn't it? Tell me something about this angle and arc AC. They're equal to each other. Now, look at this angle down here. Does this angle right here look like it's the same as this angle here? It does? No, that's a lot skinnier, isn't it? In fact, again, it's an easy relationship. I know you might not know, but just off the top of your head, what do you think?
It's half.
It's half, exactly right. Yep, you're exactly right. See, I know it's kind of intuitive. I mean, a little bit, you know, when I said it's a nice, easy relationship. It's half, okay? So this angle right here is half of its intercepted arc. We call this the central angle, this one right here. And let's just change the color so we keep everything together. This angle right here is called an inscribed angle. Remember the other day we did an inscribed quadrilateral? I don't know, do you remember the inscribed polygon and all the vertices matched up right in here? I think we did that the other day. Thought we did. So this is called an inscribed angle. Inscribed, that means the vertex of the angle, where does it lie? On the circle, that's right. It's not outside the circle, not in the circle. It's actually on the circle itself. It has to be for this relationship to be true. So watch this. I could say that angle B, the measure of angle B, if you want to put that in there, is equal to what of this arc AC? It is 1/2, that's right. So angle B is equal to 1/2 of arc AC. It's an ugly arc, but you get the idea. Or you could go around the other way. You could talk about the arc and say the arc is how much of the inscribed angle? Say it? 2 times. Good. It's double, or 2 times what? Angle B. Does that make sense? So let's just put a, oopsie daisy. Let's not grab that. Let's just grab that stuff. What if we made this, what does that look like? That looks like about 40 degrees right here. So let's say that that's 40 degrees, and then somebody said, okay, what's arc AC equal to? The measure of arc AC. What would that be?
80.
Yeah, that's easy, isn't it?
Oh.
It'd be 80 degrees. So arc AC is 80 degrees. Of course, you can go the other way around too, couldn't you? You could say, if this, if you knew this arc right here, what is this angle? You with me? Not too hard. So that's inscribed angle. A little different than central angle. If this arc right here was, 80 degrees, what would this central angle be equal to? 80 degrees, right, because the central angle is equal to the arc that it cuts off, or it's, can't even think of the word that I used. What is it? I got inscribed in my head.
Central.
The one that, the intercepted, right, thank you, Katie. It's the intercepted arc, okay? Sometimes I just lose my memory. It's part of getting old, I guess. All right, so anyway, the central angle is equal to its intercepted arc. Everybody hear me say that?
Yeah.
I know I say a lot of words, and sometimes it sounds like that Charlie Brown teacher, doesn't it? You ever hear the Charlie Brown teacher? Somebody do it. Yeah, wah, wah, wah. Sometimes, doesn't it sound like that? Sometimes you just kind of fade out a little bit, and that's all you hear in the background is somebody just going wah, wah, wah. Yeah. All right, so that means you got to snap yourself out of it. All right, try to snap yourself out of it a little bit when you hear that, and actually try to hear the words. So what did I say? The central angle is equal to its intercepted arc. The inscribed angle is equal to half the intercepted arc. You got it? So it's a very simple relationship. It's not that hard. And let's move on. All right, now we have a different circle up here. Now we're going to still talk about inscribed angles, but I'm going to do something a little bit different with these. And we'll go color-coded here. We'll go red. And we'll go to here, and nothing in particular, just right there, all right? So that's my red angles. Let's do a different color now. What do you want? How about that nice little green? Now watch this. I'm going to start at another place. They're both going to be inscribed angles, but watch what I'm doing. I'm going to here, and I'm going to right there. It's close enough. You get the idea, all right? Well, it stays blue until you click off of it, and then it turns to the color, all right? Now, it's not necessarily going through here or anything. And let's put some letters on here. We'll just do that in black. And what do we got? A, B, C, D. See, the book's not even that creative. They use the same ones all the time, don't they? B, C, D. All right, this is what's given to you. It says, let me read the theorem to you, all right? It says, if 2 inscribed angles of a circle intercept the same arc, do we have 2 inscribed angles? Yep, that's one, that's another one. They intercept, what does it say? The same arc. What is the same arc here? DA. You see, the red one hits here and here, and the green one hits here and here, doesn't it? So if that's true, If it intercepts the same arc or congruent arcs, then the angles are congruent. All right? So just looking at this, without giving any other information, I'm looking at this arc right here, and I'm saying, or this angle. This angle comes and it hits D, and it hits A right there. And I'm going to try to color it in a little bit just to, I don't know, let's go purple. So watch this. If there's the arc, I just want to, that's all right. I just want to highlight it a little bit. So there's the arc, so you see it a little bit better. So this angle hits and it intercepts this arc. Look at this angle down here. This arc down, or this angle down here intercepts the same exact arc. So think about it. If I knew what the arc was, let's just play around with it. Let's just say it's, we'll go 80 again. We used that number before. We'll use it again. Listen, oh, thanks.